Hello everyone, I'm Samiha. I'm going to present our work, Mining Software Repositories for Patternizing Attack and Defense Co-Evolution. My co-author is Mona Rahimi. So I will start with a term, moving target, which is a common term in security domain, and it means shifting the strategies of the defender to increase the complexity and cost for the attacker. So we want to introduce the same term in cybersecurity domain. What does it mean? When we write some source code, the attacker takes some actions if it is exposed to some vulnerability. Based on that, we try to change our source code, we generate some patches. And in next phase, we want to figure out if that patch actually initiates another attack. And in summary, we want to generate this triplet like vulnerability 1, patch 1, and vulnerability 2. So while the state of the art focuses on the evaluation solely, we want to focus on the co-evaluation patterns between attack and defense. We can see from this picture our problem definition. This whole attack and defense can be imagined using a chess game. When player A plays some move, some weaknesses or vulnerability might be exposed, and the attacker tries to exploit vulnerability B1. And in response to that attack, player A also plays some move, which is the patch A. And in response to that, we want to figure out what vulnerability is generated, vulnerability B2. So we are trying to figure out the probability of vulnerability B2 based on vulnerability B1 and patch A1. So in first step, we want to detect and identify the vulnerability. In second step, we want to identify vulnerability and patch pair. And in third step, we want to identify the next vulnerability. And we have some assumptions. Our first assumption is that vulnerability B2 depends on vulnerability B1. Our second assumption is vulnerability B2 also depends on patch A1. And our third assumption is our patch A1 depends on vulnerability B1. In order to conduct all these researches, we need to mine a lot of existing software repository. We have to create a large data set to infer the correlation patterns. We also have to combine heterogeneous artifacts, like some of them contain semantic information, like commit messages, and some of them contain syntactic information, like source code has some syntaxes and they have some structural properties. So we want to combine all of them. And in order to do that, we want to actually merge all the existing data sets. There are some existing vulnerability data sets, CVE, CWE, CAPEC, NVD. We want to extract all the natural language and source code information from all those resources, as well as SART data set, which contains test cases corresponding to several CWEs. And we have GitHub, which contains source code and all version information and commit messages of several projects. And we want to combine all these data sets to create a super data set, and we have to mine software repository in order to do that. And that's how we'll be create a large data set containing both semantic and syntactic information from heterogeneous software artifacts. So based on our previous works, we have classified the patterns of co-evaluation to several categories. The first one is consistency co-evaluation. So in our previous work, we studied when the source code is changed, how that change is propagated to test code to keep the system consistent. Another one is adaptation correlation. So when some API is changed, like when source code is changed and API is changed in the source code, that change is also propagated to the test code. So this is a form of adaptation correlation. And another one is optimization correlation. So it refers to adaptive changes primarily occur in response to the evolution of software adjacent agents like environment, like users and other interacting software systems. And we characterize this kind of defensive correlations which are triggered in response to the external and malicious attacks as optimization correlation. And this is the properties of patterns. It can have semantic properties and syntactic properties. Some state of the art work focuses on semantic properties like the natural language description of the source code or commit patches of the source code to detect vulnerabilities. And some of the works focuses on syntactic properties like the structural properties. So the source code have some structure, and based on those source code, they try to detect the vulnerabilities. So in our work, we propose to exploit both semantic and syntactic properties. And another thing, what is the novelty of this proposal is we want to generate the correlation patterns between attacks and defenses. So we want to generate the triplets like vulnerability 1, patch 1, and in response to those, when vulnerability 2 is generated, we want to figure out that vulnerability 2. So in conclusion, we can say that we drew attention to the patterns of correlation between attack and defense in cybersecurity domain, which is an unexplored area. We aim to mine publicly available repositories and we want to merge them. And we aim to leverage the correlation patterns to predict future attacks. Let me know if you have any questions. Thank you.